Hello everyone, welcome back to another video of this channel. So today we will be seeing about how to write a Verilog code for AND gate using data flow model, and similarly how to write a test bench. So let's write module AND. So using this kind of names is not allowed in Verilog because they are already defined functions. So instead we have to give something different because they are the main keywords. So we will be giving two input AND gate. So AND 2 is to 1. So we are giving the input a comma b comma y will be our output. So inputs are a comma b and output is y. So as you know the truth table of a AND gate, so it will give 1 when both a and b are 1, and for the rest of the cases it will be 0. So the truth table will be displayed down and the symbol for the AND gate will be displayed. So you can check out the uh, symbol and truth table to verify. So let's write the code. So as we are using a data flow model, what is a data flow model? So in data flow model, we use the symbols like and symbol or symbol instead of direct calling the and or functions. So assign y equal to a and b. You can use the double and. So I'm mostly we have to use for logically we have to use double and symbol. So a and b and end module. So this is our code for the simple AND gate with two inputs and one output. So let's see how we can write the test bench. So module tb. Always remember that we have to declare inputs as register a comma b and output as wire of y. So wire of y. So now we have to call function. So now we have to call the module name and 2 is to 1 and we have to give a user defined name. I am giving a1 and we have to call the inputs and outputs a b comma y. Now we have to write the initial begin TIL initial begin. So if you it is always sometimes it will be difficult to see the graph and see the output. So in this test bench I will show you how to display it in the section down here. So for that, for a continuous display we will be using dollar monitor. Dollar monitor helps us to display continuously the changing values of a comma b and y. So we'll be using time also. Why this is used? To show the at what time stamp how inputs is changing and how outputs are changed. So for that, so this is the general syntax of the monitor. So a equal to percentage b comma b equal to percentage b comma y equal to percentage b, and here we have to a b comma y. So it should be on order. So here we have forgot the colon. The file name I will be giving and to student.vcd. It is a file extension. Similarly, $dump vars 0 comma tb. So now we have to start giving the inputs. So at first a will be 0. We will go according to the truth table. A equal to 0. Make sure that always you end with semicolon. So b equal to 0. So after hashtag 10, this is the display of the timestamp. So after 10, whatever the units you give, like nanosecond, picosecond, it will work accordingly. So hashtag 10, a equal to 0, b equal to 1, sorry, b equal to 1. Now after another 10 units, a equal to 1, semicolon, b equal to 0. So after another 10 units, a equal to 1, semicolon, b equal to 1. So we have to end this timestamp after 10. So we have to end the initial and we have to end the module. So now let's verify. Let's run. Okay. So I have not selected, as I have told in the first video, that you have to use Icarus Verilog 12.0. So if you don't know how to write the basic code, please check my video which is mentioned in the above. So let's run. Make sure you tick mark this open EP waveform. So there is one error, $monitor. Maybe it is a spelling mistake. So as you can see, there was a spelling mistake. So this is our graph. So instead of, sometimes it will be difficult to see here. So here is our output. So you can verify it with the truth table. So here are the timestamps, here are the inputs changing, and here are the outputs. So that's all for this video. In the next video, we will be seeing about OR gate.